Okay, good day, future electrical engineers. No, so welcome back. This is me again, Engineer Jonathan Montorola. So ako ipadayon ang pag-discuss sa introduction to DC machine. Okay, this time I will discuss the principal operation of DC generator. Okay, so whenever a conductor is moved within a magnetic field in such a way that the conductor cuts across magnetic lines of flux, voltage is generated in the conductor. So it is obvious that when you have a conductor placed in the magnetic field moving, so it cuts a magnetic line of flux, and then that will result to producing an induced EMF. Okay, so the amount of voltage generated depends on, no? So magdepende siya ani, no? There are four. The first one is the strength of the magnetic field. So the MMF, no? So magnetomotive force. So if the magnetic field is strong, so meaning there are lots of magnetic line of flux, no? So therefore, if the wire or the loop of wire is moving or rotating, so ang tendency daghan kag makat nga line of flux. Second one is the angle at which the conductor cuts the magnetic field. So angle na pod, no? So magdepende, no? As it rotates, as I've said, as it rotates, makat siya og magnetic line of flux, no? So magdepende pod ang nakat nimo sa angle sa position sa imong loop of wire, no? So diha po na magdepende. The third one is the speed at which the conductor is moved. So kung kusog mo tuyok ang imong conductor, no? The rotor part of your generator, then daghan pud dako pud tagma induce nga EMF. The last one is the length of the conductor within the magnetic field. So kung taas pud ang imong length of wire or length of conductor, no, placed within the magnetic field, therefore daghan pud siya og line of flux nga makat, no, as it rotates. So as you can see in this figure, okay, so we have the loop of wire placed between the magnetic field. So as you can see here, natay north and south. So the line of flux is moving, no, in the direction from north to south. And then the loop of wire is connected to commutator segments. And then at the commutator segments, napod tay brushes connected on it, so that the output will be bring to the external circuit, which is the load. Okay, so before, in the previous slide, it was discussed that uh, the strength, no, the generated EMF depends on the strength of the magnetic field. So meaning from north to south, if there is a lot of magnetic line of flux or strong imong magnetic field, no, the EMF nimo is dako, no, that meaning dako pud taog maproduce nga induced EMF. Then the second one is the so to the length of wire, no, the length of wire. So the length of wire or dire dapita, so mas taas imong kuan, so meaning mas dako pud ang imong ma-induce EMF. Second one is the angle. So this time naka-perpendicular siya. So that means maximum ang imuhang output at this the moment. As it rotates, so mo laser siya, and then mubalik siya og zero, and then mubalik siya horizontal. So mudako na po lang atong output. So meaning changing siya, or meaning originally the output of the armature is AC voltage gina siya, no? AC or alternating ang ato ang voltage and current diri napita. Okay? So this is the principle of operation. Now, let's discuss the Fleming's right-hand rule. Now, this is applicable only to generator. Okay? So, in the generator, okay, so what is the purpose of Fleming's right rule? So, it is rule it is the used to determine the direction of the induced EMF or induced current of a conductor moving in the magnetic field. So atong ma-identify if asa the direction of the induced EMF. Also, the polarity of the voltage depends on the direction of the magnetic line of flux and the direction of the movement of the conductor. Okay? So from north to south, imo man ang ma-identify north to south, and then ma-identify po nimo, no? In that way, ma-identify nimo ang polarity niya, and then direction of the conductor or the motion, no? The force. Okay, so in this diagram, in this figure, so as you can see here, we have the north and south, no, producing a line of flux. So the direction is north to south, and then we have a blue green here, then we have a yellow green, no? So sama na siya. Apply na to og Fleming's right hand rule. So sa imong fingers, so middle finger niya, that is designates the direction of the induced current or induced voltage. The point finger nimo is represents the magnetic field, okay, B. And then the thumb nimo is sama siya, motion or force. Okay, so magnetic field, the point finger, middle finger is induced current, and the motion or force is the thumb, no? So that is, no, that is how to use the Fleming's right hand rule in identifying the direction of the induced EMF, no? Okay, so let's discuss the elementary generator. So elementary generator, ano sa may gamitan niya? Okay, so the simplest elementary generator that can be built is an AC generator. So as I've said, originally ang ato ang generator, DC generator, is an AC generator yun na siya, no? So only lang gibutangan na to og commutator, no, which is responsible of converting from the output, which is AC, to DC, no, output. Okay, so here makita na to sa diagram, sa figure nga naa sa right side. We have the line of flux from north to south, then we have a loop of wire placed in the magnetic field, then we have the brushes, we have the slip rings, okay, and a load, no, a load. Okay, so basic generating principle are most easily explained through the use of elementary AC generator. So ato sugdan sa AC generator. For this reason, okay, unahan na to discuss ang AC generator, no, before we are going to discuss the DC generator. So elementary generator consists of wire loop mounted in the shaft, no, shafting na to na diha ang loop of wire, so that it can be rotated in a stationary magnetic field. So diri stationary ang ato ang magnetic field. This will produce the induced EMF in the loop. So sliding contacts, magamit na to og brushes, connect the loop to an external circuit load in order to pick up or use the induced EMF. So pick up, no, in order to pick up the induced EMF generated in the loop of wire, so we are going to use brushes. The pole pieces marked N and S provides the magnetic field. So siya mismo, no, siya ang responsable sa paghatag og magnetic field. So the pole pieces are shaped and positioned as shown to concentrate the magnetic field as close as possible to the wire loop. As you can see, naka-curve form siya, no? So that is position, or that is the purpose of that one, that form is to concentrate the magnetic field. Kung flat siya, so daghan ta og leakage flux, no? So kung gi-curve siya, so mas mo concentrate pagid ang magnetic field, mas close pa siya sa imuhang wire loop as it rotates, no? As a loop of wire that rotates through the field is called armature, no? Katong nagtuyok, armature ang tawag ana. So the ends of the armature loops are connected to rings, mga gitawag og slip rings. So they rotate with the armature, no? So ang tumoy sa imong armature loop, connect na siya sa slip ring. Remember ha, AC generator pa ta. So they rotates the armature. They rotates with the armature, I mean. So the brushes usually made of carbon, no? Carbon brush, no? Para sa ato ang term. Carbon brush na siya. With wires attached to them, ride against the slip rings. So the generated voltage appears across these brushes. These brushes transfer power from the battery to the commutator as the motor spins. So, money. Pasabot ang voltage, no? Kay ang brush mo na siya mura siya og kumbaga mo ni ang collector, no? Mo ni mga bombay, no? Siya ang mokolekta sa output, no? Sa halin sa imuhang armature para i-deliver niya sa load. Induced EMF in a short length, no? Ato para mas masabtan pag yun, no? Induced EMF in a short length of straight conductors. So voltage is induced in a wire, moving the wire across a magnetic field so that flux cutting will result, no? So dili makakakat kung dili siya moving, no? So dapat na ang kuan na kay loop of wire, yeah, napod kay magnetic field. So mo ni ang three major components, no? The nakay loop of wire, yeah, nakay magnetic field, and then naapod kay relative motion. So kung naanata ang tulo, that means maka-generate na kay induced EMF, no? Relative motion, so kung steady lang ang imuhang rotor, that means wala kay ma-output. So this is the concept using the developing the voltage in a DC generator. EMF can be calculated in this formula, no? EMF nga ma-generate na to. Okay? Mo ni say formula. E is equal to BLV sin theta. So EMF is equal to the flux density, which is B. L is the length of wire, V is the velocity or speed of your conductor as it rotates, and then sin theta. So imo makita diri with by looking at, no, by examining the equation, the angle, no, as it rotates, if steady lang, no, steady ang imong flux density, steady ang imong L, steady ang imong velocity. So what will matter is the angle, no? The angle. So meaning sin theta man siya. So kung maabot na siya og 90 degrees, so sin 90 is 1. So meaning at 90 degrees maximum ang imuhang output, no, induced EMF. So kung mo-laser na pod, abot na ka, no, from 0 to 90, so iabot nimo 90 maximum, 91 hantod na pod sa 180, no, abot og 180, 0 na pod, then mo maximum na sa sigbalik angle 270, no. Imo makita by looking at the kuan, makita nimo kung kano sa siya mo maximum, kano sa siya mo minimum, kano sa siya mo negative maximum. Okay, so example, a conductor of length 0.5 meters is placed in a region with the uniform magnetic field of flux density 1.5 Weber per meter squared. So that is, in short, that is Tesla. What is the voltage induced in the conductor if it moves with a velocity of 30 meter per second at an angle of 60 degrees to the field? So ato sabton na kuno kay conductor nga ang length niya is 0.5 meters, nga napod kay flux density which is 1.5 Tesla or Weber per meter squared, and then na kay velocity which is 30 meters per second, nga na kay angle nga 60 degrees to the field. So what will be, no, the output, the induced voltage at that position, at that certain position? So solution, so what are the given, no? L ito, length na to is 0.5, B is 1.5 Weber per meter squared, V velocity is equal to 30 meter per second, then theta is 60 degrees. Okay, so substituting to the formula, 1.5 times 0.5 times 30 times sine 60. So the induced EMF generated at that certain angle is 19.5. So 19.5. So now, what will be the maximum generated EMF? No? What will be the maximum generated EMF? Compute the maximum. So 1.5 times 0.5 times 30. Yeah, times, para sa gina siya mo maximum when the angle is 90. So times 1. So pila man. So the maximum generated EMF is expected to fall into saman 22.5. So 22.5 ang imong positive maximum, then 22.5 negative 2.5 ang imong negative maximum o negative peak value. Okay? So proceed. So that is the answer. Okay. Proceed ta. Ato na lang sulit-suliton. Okay, 16. Okay, so elementary generator at position A. Money say position A, ha? So at this moment, loop A, no? As you can see in the dots, money ang dots A and kani loop na to. Red lines, makita mo the horizontal lines. Horizontal lines. Then this is the circle here is a shaft. Okay. At this position, okay, the loop of wire, black and white conductors of the loop is parallel to the magnetic line of flux. So this time, okay, no cutting action is taking place. So wala tay output, zero atong output dire. Kay sin 0 is 0 man. Okay? So since the flux of the line of flux are not being cut, no, wala siya na-cut. May tabo, no EMF is induced in the conductor. And the meter at this position indicates 0. So mo ni atong meter dire napita. No? Atong gigraph. Okay, position is called neutral plane. So ang tawag kanin niya neutral plane. So meaning at neutral plane induced EMF is equal to 0. At position B, no? Natay position B, the shaft has been turned to 90 degrees clockwise. So the conductors cut through more and more lines of flux. So the voltage is induced in the conductor. So at a continually increasing angle, the induced EMF in the conductors build up from 0 to a maximum or peak value. So yung makita dire at this position sa figure na to, the black dot, no, naabot na po dire sa horizontal na siya, no, horizontal position. So this time the induced EMF is maximum, no. Nagingon sin 90 is equal to 1, so meaning times nimo, so maximum na imong output. Observe that from 0 to 90 degrees the black conductor cuts down through the field. So muni yang nakat 1, 2, 3, 4, 5, 100 na pila daghan kayang nakat, no, daghan iyang nakat. Okay, so at the same time the white conductor also cuts. So nakakat pod ang white conductor. So series adding mo siya, so what will be the output of the white conductor and the black conductor? So ma-add siya, no, ma-add, series adding man. This means that the resultant voltage across the brushes is the sum of the two induced voltage. Okay, so the induced voltage of white conductor and the black conductor, i-add nimo, that will be the total, the resultant voltage. The meter at this position B reads the maximum value, no, maximum value. Okay, after another 90 degrees of rotation, okay, so 90 plus 90, 180 na, no, 180. And it is parallel again, no, parallel again. Makita diri ang black na napud sa tumoy pikas, no, the upper, and then nasa ubos ang white. Okay, as the loop was turned, the voltage decreased until it again reached to 0. So ma-0 na pod. Yung makita diri ang reading, no, ni maximum siya at 90 degrees niya, ni down siya, no, pag 180, no? Pag 180. So note that from 0 to 180, the conductor at the conductors at the armature loop have been moving in the same direction through the magnetic field. So masero na po ni. So therefore, the polarity of the induced EMF has remained the same. Position D. Okay, position D na to. As the loop continues to turn, the conductors cut again, no? The line of flux. So may tabo. This time, however, the conductor previously cut through the flux lines of the south magnetic field is cutting the line of flux magnetic field, no? There is a north magnetic field. So bali na pud siya, no? Nabali siya and vice versa. So diri na pud siya sa negative peak. Okay? Since the conductors are cutting the flux lines of opposite polarity, opposite magnetic polarity, so the polarity of the induced EMF, induced voltage is reverse, no? Reverse pod. So negative. So after 270 of rotation, the loop was rotated to the position shown. No, kana diyan nakita na to sa figure. Okay, and the maximum terminal voltage will be the same as it was from A to C, except that the polarity is reversed. Okay? So same ra siya og maximum, same ra siya value. The only difference is ang iyang polarity. So negative lang iyang polarity. Okay, so after another 90 degrees of rotation, total of pila naman 360, it returns to its starting position. Makita na po na to, no? Ang white na po sa babaw, ang black na po sa ubos. So this decrease, no, from its negative peak back to 0. So one complete cycle na siya. One complete cycle. Okay, so notice that the voltage produced in the armature is an alternating polarity. So muna akong gingon ganina, normally or originally, the output of the armature is alternating, yun na, alternating current, alternating voltage. Okay, so this time, by looking at the figure, position A 0, position B positive maximum, position C at 180 0 na pod, position D negative maximum, no, diri sa pikas, at B positive maximum, at D negative maximum, no, 270, and position A back to 0. Okay, 0 na pod ang reading. So observe meter direction, no, meter direction tanawa, at position B here counterclockwise, position D clockwise na pod, no, clockwise. So since DC generator must produce DC current instead of AC current, a device must be used to change the AC voltage produced in the armature windings into DC voltage. So DC voltage na siya. Unsa man nga device, mo ning gitawag na tuog commutator. No, ay makita diri sa loop sa figure, natay loop of wire, natay brushes, and then at the same time natay commutator. Okay, so mo ang gitrabaho, mo ang trabaho sa commutator. Commutator is constructed from a copper ring split into segments with insulating material between the segments, no? Insulate ginanimo para di sa mag-short circuit. Brushes riding against the commutator segments carry the power to the outside circuit, no? O imong load, no? So siya na ang mo kolekta sa output, and then iyan dadon sa external circuit, outside circuit. The commutator in a DC generator replaces the slip rings of a AC generator. This means this is the main difference in their construction. So mao gini akong ingon ganina sa previous video, the only difference of AC machine to DC machine is the slip ring and the commutator. So commutator is to DC machine AC generator is to slip ring, no? So muna na iyahang logic. Okay, so the commutator mechanically reverses the armature loop connections to the external circuit. So siya na ang automatic mo reverse, no? Mechanically reverse the loop connection. The armature has an axle. No, siyempre ato nato i-butang natin axle, and the commutator is attached to the axle. Kita dito sa figure natin axle kanang black, no, hole. So in the diagram the right, you can see three different views of the armature: front, side, and end-on. Okay. So in end-on view, the winding is eliminated, no, to make the commutator more obvious. Okay, so nakita nimo diri mo ni ang end-on, no? Mo ni ang front, mo ni ang back. Outside, I mean. So we can see the commutator is simply a pair of plates. A pair of plates lang gina siya. Pair of plates attached to the axle. No, mo ni ang axle na to kanang black. So mo ni ang iyang commutator kani siya. No? Commutator. Okay? So these plates provides the two connections for the coil of electromagnet. Okay, provide connections. Okay, so electromagnet. Okay, so the elementary DC generator, no, commutator and brushes work together. The diagram, mo ni diri ang diagram. Okay, so sila duha, no, brushes and commutator work together. So, how commutator and brushes work together to let current flow to the electromagnet, and also to flip the direction that the electrons are flowing at just the right moment. The contacts of the commutator are attached to the axle of the electromagnet, so this spin with the magnet. So this spin with the magnet. The brushes are just two pieces of springy metal or carbon that make contact with the contacts of the commutator. Okay, so brushes are two pieces. Depende. And then through this process, the commutator changes the generated AC voltage to a pulsating DC voltage, at which also known as commutating process. So pulsating DC voltage, pulsating DC voltage. So that is how the commutator and brushes work together, no? Work together. So pag tuyok niya, tuyok ang imong armature, tuyok pod ang imong spring, tuyok po ang armature, no? Tuyok po siya. Okay? So the loop is parallel to the magnetic lines of flux, no? And no voltage is induced to the loop. Mo ni siya. Kana. Okay, at this loop, zero, wala kay na produce. No? Yung makita diri, mo na imong commutator, so nag-abot silang duha, no? Nag-abot dinhi sa usa ka kuan sa in between nila, no, sa both ends nito. So note that the brushes make contact with both of the commutator segments at this time. So the position is called neutral plane. So ganina neutral plane to sa atong AC generator. So this time neutral plane sa ato ang is DC generator. As the loop rotates, okay, so balik ko na ko. We are done with AC generator, elementary AC generator. So we are in elementary DC generator na ta. As the conductor begin to cut through the magnetic lines of flux, so mana siya diri, tuyok na siya sugod. So at 90 degrees, So the conductor cutting through the south magnetic field is connected to the positive brass. So positive brass. Okay? And the conductor cutting through the north magnetic field is connected to the negative brass. Makita nimo diri sa diagram, ang kani siya nga brass naka-connect sa north. Kanang black. Ya, kani ato diri pikas nga kuan naka-connect sa south. Okay? South. So, at this moment, cutting lines of flux, a voltage is induced into the loop. Kita na to diri, mo ni atong meter reading, no? Maximum siya. So, after 90 degrees of rotation, the voltage reaches of its most maximum point, no, or most positive point, no? Kita na to diha. So, as the loop continues to rotate, the voltage decreases to 0. Kita na po na, padung na po 0. Pero nabali na po ang atong loop. Na imo kita diri ang black wire na napod sa babaw, ang white wire napod sa ubos. Okay? Napod sa ubos. One element, another element is on the other side. Okay? So, after 180 degrees of rotation, the conductors are again parallel to the line of flux, and then no voltage is induced. So, note that the brushes again make contact with both segments of the commutator at the time when there is no induced voltage in the conductor. Wala, no? Wala na generate at 180. During the next 90 degrees of rotation, the conductors again cut through the magnetic lines of flux. No? Kita na po nato diri. No? Rotate na po. Ang ato diring black nga wire nasa south, ang white wire nasa north. So this time, however, the conductor that was previously cut through the south magnetic field is now cutting the flux of lines in the north field and vice versa. No? Nabali na po. So this time, since the conductors are cutting the lines of flux of opposite magnetic polarities, the polarity of induced EMF is different for each of the conductor. The commutator, however, maintains the correct polarity to each brush. Bisan pag nausab pa na ang white na sa north, ang black na sa south, the commutator remains, no? Iyang gipabilin ang polarity sa imuhang induced EMF. Wala niya giusab, wala niya gipa-usab. The conductor cutting through the north magnetic field will always be connected to the negative brush. And the conductor cutting through the south field will always be connected to the positive brush. Muna siya ang trabaho sa commutator. No? Siya mag-maintain. No? Siya yan ang i-maintain ang polarity. Since the polarity of the brushes has remained constant, wala man no usab, no? Same gyapon, yung north, south, maura gyapon. So, maura gyapon ang iyang graph, no? The voltage will increase to its peak value in the same direction. Okay. Next is, as the loop continues to rotate, the induced voltage again decreases to 0 when the conductors become parallel to the magnetic lines of flux. Kita na po na to diri. Another 90 degrees. Okay, balik na po siya og ka-0. Notice that in 360 rotation, okay, remain ang iyang polarity. This is called rectified DC voltage. May makita diri. Rectified DC voltage, no? Or pulsating direct current. Pulsating direct current. So, taas pa kay ang ripple voltage, no? Kita nimo diri. 0 maximum, 0 maximum. So, if you have a load which is sensitive to the amount of voltage, then on and off ang mga supply, no? Yung mga siga, kung suga man siya, so on, off na sad, on, off, ano. The voltage is pulsating. It does turn on and off, but it never reverses polarity. Since the polarity for each brush remains constant, the output voltage is DC. So DC, puro pulsating na siya. So mo na po ni na natay diagram dire. Position A, okay, sa 0 degree, walay na create na voltage, Position 90 at B, so na maximum, positive maximum. C 0, then D maximum na pod, no, same gyapon direction, positive maximum, and then at balik na pod ta sa position A, 0 na pod C. Okay, effects of the additional turns. So additional turns, to increase the amount of output voltage, it is common practice to increase the number of turns of wire for each loop. So para mudako pa gid ang atong output voltage, padaghanan nato ang saman turns of wire in the loop. Mo ni siya. So ganina usa ra man to ka wire, so this time pila na ko 1 2 3 4. So upat ka wire kada element, no? Meaning this element is 4, so another 4, so 8 conductors, no? 8 conductors per coil siya. So if a loop contains 20 turns of wire, and in those voltage will be 20 times, no? 20 times greater than the single loop conductor. So the reason for this is that each loop is connected in series with the other loops. Since the loop form a series path, then the voltage in those in the loops will add. So kung tag 2 volts ang kada coil, so all in all natay 40 volts nga output, no? 40 volts nga induced EMF. That is the result of additional turns. Effects of additional coil. When there are more coil, one loop, when more than one loop is used, the average output voltage is higher and there is a less pulsation of the rectified voltage. So kani. Okay? So daghan pagid kayo ang loop, no? For example kani. Natay pila ka loop. So kanina, one loop lang to, karon 2 loops na, no? Additional coil. So since there are 4 segments in the commutator, a new segment passes each brush every 90 instead of 180. Ganina ang output na to ganina mula hose mo to dire, then gisaw naman sa ikaduhang ka coil, so dire sa taman di mapunan, no? Cut na saw na po sa lain, so money. Okay, so kung ari patag electronic ani gamit na taog saman kapasitor, no, para ma-reduce na to ang ripple voltage. Okay, so this time gamit niya number of loops additional, no, and number of coils. Since there are 4 commutator segments, upat na, there are 4 in the commutator and only 2 brushes, the voltage cannot fall any lower than point A. Point A. Naman niya atong point A. So, dili siya mo ubos. Sa may atong brush. Therefore, the ripple is limited to the rise and fall between points A and B on the graph. By adding more armature coils, the ripple effect can be further reduced. So decreasing ripple in this way increases the effective voltage of the output, no? So kung mabantayan nimo daghan ka og commutator segments or commutator bar, ano man daghan pod ka og coils, no? Daghan pod ka og loop. So kung daghan ka og loop, okay, aside nga daghan ka og aside nga daghang coil, no? So mas ang imuhang ripple mo gamay, no, ripple voltage. So mo increase pod ang ihang effective voltage sa output. Okay, and the actual construction and operation of a practical DC generator differs somewhat from our elementary AC generator. So mo ni makita na to, no? 4-pole generator without armature. So this is the stator, no? This is the stator that contains the field windings. So mani ang field windings nato, no? So you can see here, wind ka diri sa first nga pole, then pagkahuman, okay? So imo makita diri ha, diri ka niagi, no? Diri ka niagi, ngadto, diri ka ni gawas. Pero pag sunod nga pole, okay, south man ayo pag diri sud sa babaw na sad, diri na pod kaagi sa ubos para mahimo sang north, no? No, diri na pod pag abot ta sa diri na pod kaniagi sa babaw, no? Diri na pod ka gawas sa babaw, no? Diri ka ana. Yeah, balik tas ka sud, gawas na diri pod babaw. And then we have here, unsa man itawag ani? Okay, diri na pod ta mo adjust sa ato ang saman. Kung ang atong field windings, no, is no, ang atong kumbaga, I mean, the supplier of magnetic field is a field winding or winding, nasa winding, we can easily control the strength of the magnetic field, no, by adjusting the input voltage, no, on it. Okay, so nearly all practical generators use electromagnetic poles. Electromagnetic poles, say pasabot kung electromagnetic pole uses windings and na kay armature core. So kung imong supplyin, energize nimo ang winding, then na kay electromagnetic na output. Instead of permanent magnet used in our elementary generator. So instead of using permanent magnet, okay, so gamit ta og field windings o electromagnetic poles. The main advantage of using electromagnetic poles are, sa may advantage niya, first is increase field strength, no? Ma-increase na to. So kung permanent magnet, steady lang siya, and then magkaanam sa ka-weaken ng imong magnetic strength. Number 2, possible to control the strength of the field. Mo na yung gingon, no? Adjust mo. By varying the input voltage, the field strength is varied. By varying this field strength, the output voltage of the generator can be controlled, no? So ma-adjust po na to, no? Adjust. So dali ra nato ma-adjust ang output voltage, no, kung gamit ta og electromagnetic poles. Okay, generated EMF in the armature. So flux cut by one conductor in one revolution of the armature is this one. Okay, so mana changing man, no? So the flux is equal to number of pole times the flux, no, in Weber, no? So time taken to complete one revolution, so in one revolution we have, okay, dt, no, changing man with respect to time. So 60 over number, no, speed na nimo, speed n. So average MF generated per conductor is, okay, d flux over dt, no, volts. Substitute, we have, okay, P flux divided by 60 over n. So imong i-simplify, we have P flux n over 60. Okay? So since there are number of armature conductors connected in series per parallel current path, so therefore napunta ni nga formula Z over A. No? Z over A, where A is the number of current parallel paths. So ang A na to mag-agad po na nato, pag-agad po na sa imuhang flex factor. Unsa man ang flex factor? Flex factor is simplex, duplex, and triplex, no, depende, no, napatay quadruplex. So A is equal to 2m twice the flex factor when the armature winding is wave. A is equal to MP if the armature winding is lap. So, substitute na nato, no, i-multiply na nato, no, sa kani. Okay? So, generated EMF is equal to P flux N over 60 times nato sa kay daghan man ang number of parallel conductors, no? Number of armature conductors, yeah, over sa series or the number of parallel paths. So, times na to sa Z over A. Therefore, the original formula or the formula for generated EMF with respect to the number of poles, flux, number of series conductors, and speed over the number of parallel paths, current parallel paths. So, epsilon over 60A. No? Epsilon. So, when ang atong flux diha is in terms of taman Weber, no? Weber. When ang flux is in terms of Maxwell, so mo pa ni atong formula. Epsilon over 68 times na to times 10 to the power of negative 8. Kung ang atong kuan is in Maxwell. Watch out lang mo. Huh? If the line of flux or the flux per pole is expressed in Maxwell's, so therefore use the formula which is epsilon over 68 times 10 to the power of negative 8. If the line of flux is in Weber, so therefore use the epsilon over 68 only. Okay, so let's have an example. A 4-pole DC generator has a 124 simplex lap coils, each having 2 turns. The flux per pole is 0.015 Weber. Calculate the voltage appearing across the brushes when running at 1,500 RPM. Okay? So, sabot-tabo lang kayong pangutana, no? So, 4 pole, so that is your P124 simplex lap coils. Yan naman si condition, having 2 turns. So, 2 turns, meaning 2 turns, yeah, simplex lap coils. So, remember, 1 coil has pila ka element? 2 elements. Okay? Okay. Then, flux per pole is 0.15 Weber. Speed na to is 1,500. So, remember, 2 turns per coil, no? Therefore, malakong ginggawin nila, 1 coil is equal to 2 conductors or 2 elements. So, 4 conductors per coil. So, by using the formula, epsilon over 60A lang, kay Weber man ang atong flux per pole. So, substitute, we have this one. 4 times 1,500, which is your N, no? And 124 coils times 4 conductors per coil, no? Times 0.015. All over 60 over 1 times, 60 times 1 times 4. Hindi makaaning 1. So, kay lap man siya, so supposedly, MP siya, no? Complex factor times the number of poles. So, since it is stated in the problem that it is in simplex lap winding, no? So, simplex, so meaning 1. So, mana nga 1 times 4 ni siya. 60 times 1 times 4. Okay? So, solving out, okay? So, we have a generated EMF of 186 volts. No? So, kindly solve that one in your own calculator. No? Para mas masabtan pa gid. Remember lang, 2 turns, no? 2 turns, pila man ka conductor per coil. So, we have 4 conductors. 4 conductors. Okay? Okay. So, I hope you understand the topic. No? Hopefully, you understand the topic. And this will be the last slide, no, for this video. Kay naabot na taog 49 minutes. No? So, see you in the next part of the video. We're still in the introduction to DC machines. So, practice, no? More problem sets, no? Kung ihatag unya. No? God bless everyone. And keep safe.